Welcome back to section 6.1 for Math 95. This is part 2 of the video. In this part, we're going to look at multiplying and dividing rational expressions. In a nutshell, to multiply rational expressions, you're going to factor everything, multiply straight across, but don't actually multiply the factors back out, and then simplify by canceling common factors. Let's look at some examples. First, I have 3x over 8 multiplied by 2 over x squared. Now, each of my fractions here has a single term in the numerator and in the denominator, so there's nothing to factor. That means I can move on to multiplying straight across. 3x multiplied by 2 over 8 multiplied by x squared. Now I can simplify this a bit more. This is 6x over 8x squared. Now that I've multiplied straight across, I take a look and see if there are any common factors that I could cancel. I noticed between the x and the x squared that I have a single x on top and two x's on the bottom, so I'm going to be able to cancel something there. I also noticed between the 6 and the 8 that they're each divisible by 2, so I'm going to be able to cancel something there. Now, it wouldn't surprise me if most of you could write down the simplified version right now, but I'm going to put in another step just to help you see what's really going on with this cancellation. Like I said with the 6 and the 8, I noticed that they're both divisible by 2, so that 6 can be rewritten as 2 times 3, and I've still got an x here. And the 8 can be rewritten as 2 times 4. And then I have two x's. X times x for x squared. Now it's a little bit more obvious how things cancel. There's a 2 on the top and a 2 on the bottom. There's a single x on top and a single x on the bottom, which leaves me, finally, with a 3 on top and 4x on the bottom. Now let's take a look at this second example. Notice that everything is already factored for me, which is great. So all I need to do is multiply straight across and then cancel out any common factor. Now when I say multiply straight across, I just mean write down the top of this one multiplied by the top of this one on top. So I have x plus 3, 2x minus 1, x minus 2, 3x minus 1, and then do the same thing on the bottom. X minus 2, 3x plus 4, 2x minus 1, x minus 4. You do not need to multiply this stuff out. You can leave this in its factored form. In fact, not only do you not have to multiply these guys back out, please don't. It will make everybody's lives easier if you leave it in its factored form. So now I've multiplied straight across, and I'm looking for any factors that I can cancel. I see that I have an x plus 3 on top, 2x minus 1, x minus 2, 3x minus 1. Are any of those repeated down here on the bottom? Looks like there's an x minus 2 on top and bottom, and also a 2x minus 1 top and bottom. I don't see anything else that's exactly the same, so I'll go ahead and write out my final answer as x plus 3 multiplied by 3x minus 1, that's what's left on the top, and 3x plus 4 multiplied by x minus 4 on the bottom. And I'm going to say one more time, you don't need to multiply this back out. You can leave your answer just like this. I'll be happy. The answers in the back of the book are written like this. Everybody's happy if you just leave it factored. Finally, before I move on from this example, I want to point something out to you. You may remember back when you were multiplying just fractions with numbers that you could cancel before or after you did the multiplication. The same thing is true here. I could have looked at this problem and canceled a 2x minus 1 from top and bottom and an x minus 2 from top and bottom and then multiplied straight across, and I would have ended up with exactly the same answer. That's always the case. You can either multiply and then cancel, or cancel and then multiply. And now I've got one more example where it looks like we're going to have to do the factoring. My first expression is 2x minus 3 over 5x. There's nothing to factor there, so I'm just going to write it down again. It's 2x minus 3 over 5x. Then between 5x plus 5, it looks like they both have a 5, so I can factor out that greatest common factor, leaving me with 5 times x plus 1. And then on the bottom, I've got a trinomial, which I can factor using the a times c method. I went ahead and did this off to the side, but it should factor as 2x minus 3 times x plus. Feel free to take a moment to both make sure that you agree with this factorization and that you feel comfortable getting from this step to this step on your own. Now that we have everything factored, we'll go ahead and see if there's anything that we can cancel. I see that I have a 5 on the top and the bottom, and I also seem to have a 2x minus 3 and a 2x minus 3 on the top and the bottom. Now I'll finish up by multiplying straight across. I have an x plus 1 on top, an x on the bottom, and an x plus 3 on the bottom. Now I'll go ahead and leave my final answer like that without multiplying it back out. And of course, now I have a couple problems for you to try. Before you start, notice that this problem has everything factored for you already, so all you need to do is multiply and cancel. And then this problem, you're going to have to do some factoring. And for this x squared minus 1 and x squared minus 4, let me give you the hint that you're going to want to try a difference of squares to factor that. So go ahead and pause the video, work on those problems, and then come back when you're ready. And we're back. On this first example, I decided to multiply everything straight across and then cancel. Notice that I moved the 4x to the front. It really doesn't matter what order the terms go in since everything is being multiplied. It's just a habit of mine to keep the single term type things up at the front where I can more easily notice when something will cancel. So then I had an x plus 2 on top and also an x plus 2 on the bottom. I had a 2x minus 7 on top and bottom, so I canceled all of that. Between the 4 and the 2, I noticed that 2 goes into 4 2 times, leaving a 2 on top and a 1 on the bottom. And then I had an x on top and an x squared on the bottom, so those will cancel, leaving a single x on the bottom. And then I rewrote that mess to clean it up a little, and I had 2 times x minus 3 on top, a single x, and then an x plus 5 times x plus 5 for the bottom. Now it's perfectly fine to leave your answer like this, but I noticed that I have x plus 5 times x plus 5 on the bottom, so I could push those together and call that x plus 5 squared on the bottom. For the second example, notice that we needed to factor things. So I have x plus 2 over x minus 1 as one of my fractions, and then x squared minus 1 factors as x plus 1, x minus 1, and x squared minus 4 factors as x plus 2, x minus 2. Now I'm ready to multiply straight across. Notice that when I multiply, I treat the top and the bottom of my fraction as a single term. So I end up with x plus 2 in parentheses multiplied by x plus 1, x minus 1, and on the bottom, x minus 1, x plus 2, x minus 2, just multiplying straight across. Then I look and see what I can cancel. I have an x plus 2 top and bottom and an x minus 1 top and bottom, which leaves me with an x plus 1 on the top and an x minus 2 on the bottom. Once again, you can leave your answer as x plus 1 in parentheses and x minus 2 in parentheses, and that's perfectly fine. But these grouping symbols, the parentheses, aren't really doing anything anymore, since the fraction bar is also a grouping symbol, and it's grouping this into top and bottom already. So it's okay to drop the parentheses if you want to, and leave it as x plus 1 over x minus 2. Our next topic is dividing rational expressions. This really isn't that much different than multiplying rational expressions. Do you remember what you did when you divided fractions? Hopefully you remember that when you divide fractions, you flip the second fraction and then you multiply straight across, just like regular multiplication. Dividing rational expressions is just the same idea. We will flip the second one, multiply straight across, factor everything we can, and then simplify. Notice that from here, multiply, factor, simplify, it's just the same steps as multiplying rational expressions. So let's go ahead and do an example. I'm going to divide these polynomial expressions. My first step is to flip the second expression. So I write down the first one just the way it was, and then I flip over the second one and put a multiplication sign in between them instead of a division sign. Now this should look just like the multiplication problems that we were doing earlier. So we really haven't added anything new except this first step where we flipped the second fraction. So I'm going to go ahead and multiply this straight across and then see if I can cancel anything. When I multiply straight across, I get x squared, x plus 2, 2x minus 3, x plus 7 over 2x minus 3, x plus 1, I've got an x cubed here, an x plus 2, and a 3x minus 1. Notice that everything is already factored, so all we need to do now is look for things to cancel. I see that I have an x plus 2 top and bottom, and a 2x minus 3 top and bottom. And then finally, I have an x squared on the top and an x cubed on the bottom. I have 2 x's on top, so those are both going to cancel out. There were 3 x's on the bottom, so canceling out 2 of them will leave a single x on the bottom. So my final answer here, when I clean this up a little bit, is x plus 7 on top, an x plus 1, and a 3x minus 1 on the bottom. Let's do another example. It looks like this time we're probably going to have to factor some things. Still, my first step when I see one big thing divided by another thing is to flip the second one and rewrite it as multiplication. Then we'll worry about what happens from there. So I leave the first one alone, x squared plus x minus 6 over x squared minus 1, write down multiplication instead of division, and flip over the second one, 2x plus 2 over x plus. Now that we've changed this from division to multiplication by flipping the second one, we'll go ahead and follow the steps for multiplying any two rational expressions. We'll factor everything that we can, and then multiply, and then simplify. On my first numerator here, I can factor this as x plus 3, x minus 2. It's a trinomial. On the bottom, I have x squared minus 1, which is a difference of squares, and factors as x plus 1, x minus 1. On my second fraction, I notice that 2x plus 2 has a 2 in it that I can factor out, leaving me with 2 times x plus 1. And on the bottom, x plus 3 doesn't have anything in common between those two factors, so I'll just write it down as a single factor. Now, finally, I can cancel anything that I have in common on top and bottom. Looks like I have an x plus 3 top and bottom, and an x plus 1 top and bottom. So I can finish this up by multiplying straight across. I have a 2 times x minus 2 on the top, and an x minus 1 on the bottom. And of course I have one for you to try. So go ahead and pause the video, and then try doing this rational expression division. And when you're ready, you can start the video up and we'll talk about the problem together. And we're back. So the first thing I noticed on this problem is that it's division, which tells me right away that I'm going to flip the second one and change the sign to multiply instead of divide. So now I have 3 over x plus 1 times 2x plus 2 over 6x. Now that I've dealt with the division, I'll factor everything in sight and then multiply across. 3 doesn't factor, x plus 1 doesn't factor, 2x plus 2 I can factor a 2 out of, leaving me with 2 times x plus 1, and 6x doesn't really factor any further either. Now I go ahead and multiply everything straight across. 3 times 2 is 6, and I've still got the x plus 1, and then x plus 1 times 6x is the same as 6x times x plus 1. Finally, I see if I can cancel anything. I've got x plus 1's on top and bottom. I've also got 6's on top and bottom, which leaves me with an x on the bottom. Don't forget to put that placeholder 1 on top so that you still have a top and bottom to your fraction. That's it for part 2 of section 6.1, multiplying and dividing rational expressions. Now there's one more topic that we need to cover, which is finding the domain of rational expressions. So go ahead and watch the last video for section 6.1 to learn how to find the domain of rational expressions.